Hey everybody! In today's Stand Dynamics podcast, we're going to talk about one of the more iconic trees of the American West. We'll cover some of the different aspects regarding the processes and patterns that influence the stand dynamics and structure of Ponderosa Pine, also known as Pinus ponderosa. Ponderosa pine is one of the most widely distributed pines in western North America and is a well-known part of the landscape. Its range extends from British Columbia in Canada down into Mexico, and from the Pacific coast as far east as western Nebraska and Oklahoma. There are two varieties of Ponderosa pine, Pacific Ponderosa pine and Rocky Mountain Ponderosa pine. However, they are still one species. According to the Society of American Foresters, Ponderosa pine is also a major component of three different forest types: the Interior Ponderosa pine cover type, the Pacific Ponderosa pine cover type, and the Pacific Ponderosa pine Douglas fir cover type. Historical accounts of mature Ponderosa pine forests before the West was settled describe them as open and park-like structures. However, spatial patterns in these forests have changed over the history of the stand and with the quality of the site. Distribution patterns of plants across different environments give us information about stand history, stand dynamics, and interactions between plants. So when we look at trees and pine stands today, their distribution across the forest and across the stand is a response to age, climate events, and various disturbances. We'll begin our exploration into Ponderosa pine forest structure by looking at Ponderosa pine regeneration, or the establishment of new trees into a forest. Except in the Black Hills of South Dakota and the west side of the Sierra Nevada mountains in California, the natural regeneration of Ponderosa pine is sporadic and thought to be the chance result of the combination of a heavy seed crop and favorable weather during the following growing season. So, in contrast to areas like the Black Hills and the Sierra Nevadas, which I just mentioned, regeneration in locations such as the Colorado Front Range, Eastern Oregon, and here in the Southwest is highly dependent upon those precipitation patterns and temperature conditions in late spring. Additionally, regeneration in these areas depends on an adequate seed production, which only occurs every few years, adequate soil moisture, protection from frost, and a lack of competition from shrubs and other grasses. The germination and establishment of Ponderosa pine seedlings tends to occur near small established trees and roughly 15 to 35 meters away from the largest canopy area. This may be optimal for regeneration because these trees provide adequate seed supplies. This area is still near enough to be within the dispersal distance for Ponderosa pine seeds, and it is still far enough away from the trees to avoid shading from the canopy and litter fall. Studies of spatial tree analysis in Ponderosa pine stands demonstrate that trees establish in episodes of small groups, and that the number of trees in these clusters declines as trees grow and compete with each other, leading to thinning in the stand. Thus, as the stand ages, tree distributions tend to become more heterogeneous and trees become scattered into even-aged clusters. However, we must note that these tree clusters are not always associated with canopy openings. The saplings may be positively associated with medium-sized overstory trees, or they can be independently distributed. But once the new seedlings become established, their relationship with overstory trees does become competitive, which is a large factor in stand structure and is an important component of what you see happening around you in a Ponderosa pine forest at any given point in time. Disturbance is also another important contributor to a forest's structure. Substantial variation in Ponderosa pine spatial patterns throughout its range probably reflect differences in the history of disturbance by grazing, fire, and human activity in the forests. Ponderosa pine systems are adapted to frequent low-intensity fires. These pre-settlement, low-intensity, high-frequency fire regimes played a significant role in structuring the current spatial pattern of large trees. Surface fires burn through a stand, and clumps of smaller trees are killed because they have not yet developed fire-resistant bark. This leaves larger trees alive and possibly more regularly spaced within the stand. Animals are another significant disturbance factor. Small mammals that cache seeds impact seedling regeneration, as does cattle grazing. Cattle grazing may increase seedling mortality through trampling, or it could foster seedling success by reducing competition from grasses and eliminating the fine fuels that would carry surface fires throughout Ponderosa pine's range. Ultimately, disturbances can be a significant influence to a forest's overall structure. In conclusion, work throughout Western North America demonstrates the existence of common spatial patterns and stand dynamics in old-growth ponderosa pine forests repeated across the landscape. Regeneration initially results in a clumped distribution of seedlings. During the stem exclusion stage of forest development, self-thinning of even-aged stands from competition leads to a more random distribution of stems within that stand. And eventually, a more regularly spaced mosaic of uneven-aged groups of ponderosa pine trees occur. This gives rise to the various ponderosa pine forests we all see today in the western United States. I hope you've enjoyed learning a little bit more about ponderosa pine forests and their structure. I hope when you're out hiking in ponderosa pine forests today that you can look around the stand and see the various events and factors which have contributed to the spatial pattern of trees today, and enjoy a little bit more of the forests than you previously did. Have a great day.